Hi everyone and welcome back. So in this video, we are going to set up our streamer clients. So I've created a bare-hand project with the dependencies added in. We have WebSocket, JSON, WebRTC, Navigation Compose, Heals, my favorite library, and also View Model library. After adding these libraries to our project, let's start with the initial setups inside our project. I'll add the permissions first, like this, and then go back to my main route and add my structure as usual. So I'll have the DI dependency injection package removed for our socket client, UI package which has the components, navigation themes, and also the screen and the view model package. So let's start with adding our app module. I'll copy and paste it here. It's pretty much simple module. It's a singleton component and we are providing the JSON object like this. And then let's go to the lowest possible layer, which is WebSocket client, and create our Kotlin class called remote socket client. This class is responsible to connect our Android device to the WebSocket or signaling server of our Oven Media Engine. This class is going to be injectable and it'll have the constructor with the JSON object inside it. So we will have a socket client object of type WebSocket client, and it's going to be null initially. Let's have the init function which gets the socket URL of type string and the listener of type remote socket server listener, which I'll create in a second. So let's create this interface named remote socket server listener. It's going to have 4 functions. I'll copy and paste it. Whenever the socket gets opened, closed, errors, and also receive a message. And we will add this message model inside our util package, just like that. This structure is the message model of our Oven Media Engine. I'll explain to you in a second. If we go to Oven Media Engine site and go to streaming part and WebRTC streaming, we'll scroll down and we will see to start connection to this Oven Media Engine, we'll have a JSON object with the command. So this command is pretty much the same inside all of data models that is being transferred, sending or receiving this. So we will have a command variable which is string, and also we will have an ID which stands for ID or stream, and then we will have an object of stp which is this one, my session description. You'll see there's a type and there's an stp, both of them are string. And also I'll have a list of candidates which are the candidate objects that I have inside my message model class. Just like that, there's a candidate of type string, SCPM line index type int, and CPMID of type string. So this is my message model with the command of type string, ID, STP of type my session description, and also the candidates, which is going to be list of ICE candidates, and also 2 extension function to convert these ICE candidates and session description to the real WebRTC session description. Pretty much straightforward. So let's import this one here and go up here inside the init function. We want to check if socket client is null, then we want to initialize everything. So socket client will be initialized anonymously and it's going to extend WebSockets client with the URI, and we'll pass the socket URL to it. So let's open brackets and implement the members that it requires. Okay, so when the socket starts or opens, we want to use listener and call on remote socket client open. Same goes for unclose, client close. Also, same goes for the on error, and we will pass the ex to it. But for the on message, first we want to run catching JSON from JSON. We'll pass message to string, and then pass message model as the blueprint class to convert it back to our message model. So we will check if it's success. We want to use listener and pass the on client message to it. Simple as that. And after all, after initializing this socket object, we want to add an apply block and press connect. Also, we will have a function which is responsible to sending data to host. It's going to get a data of type any. And then we use run catching and use socket client.send JSON to JSON and pass data. Simple as that. Okay, so the next thing to do before we dive to the view model and start our streaming process, I want to add my WebRTC package. And instead of writing it, I'll explain to you everything that what's going on here. I'll have my own personal, my peer observer class, which is an open class to implement all these functions, override function from the peer connection observer. So I can use this observer as the main observer of WebRTC and use every function that I want. And same goes for my STP observer. It's a convenient way to reduce implementing all the override methods. Let's go inside my WebRTC factory class. It's going to be an injectable class which has application injected inside it. So first thing to do in this class is to start initializing our WebRTC factory or peer connection factory. You can see inside this init block, we have the init peer connection factory, which requires a context. We'll create the options of type initialization options. And then using peer connection factory, press the initialize function and pass the options to it. We will initialize our peer connection factory. Right after that, we want to create peer connection factory, not initialize. So using peer connection factory builder, we will set the decoder and encoder and also set some options to it. We will create a peer connection factory. Now we have our I server and the context here. We want to set up a convenient way to start our local video source or local video stream. So to do that, first let's add this stream ID. I forgot to add my application class. Let's add this my application class. It's going to be annotated as built Android app. It's going to extend application. And inside this class, I want to create a companion object which has a stream ID with 3 letters length. So let's go to the WebRTC factory. Also, do not forget to add this inside your manifest with the name of my application. Okay, so let's close everything that we don't need here, like this. Okay, let's see what happens if we want to start a local stream. First thing to do, we will have a function called init surface view. This one is responsible to initialize your surface view renderer using these functions and also gets the EGL based content to initialize the surface view. And after that, you'll see that we will initialize the surface view and then start the local video. So this flow goes for preparation of the local stream. Let's take a look at our start local video function. First, we'll create a surface texture helper using EGL based context and current thread. And then we will have the video capturer object of type camera video capturer. We will initialize it using this get video capturer like here. All it does, it creates a camera to illuminator and starts the back facing camera. and returns the camera video capture to this variable. So after creating the capture, we will initialize it using the surface texture helper and also the context and the local video source capture observer. Let's take a look at what is the local video source. It's a video source that is being created by Peer Connection Factory lazily, and also same goes for local audio source. So let's go back down here. You'll see we want to initialize the video capturer and then start capturing. As soon as we started the capturing, we will have the local video track initialized using Peer Connection Factory. So we will create the video track, we add the ID plus the video tag to it, and add local video source to it. And we want to start previewing this track inside my surface that is being derived from this function, which is derived from the start or prepared local stream. So after creating the local video track, we want to start a local audio track. It's almost the same as the video track. We'll create it using the Peer Connection Factory, and for the tag we'll add the audio tag to it, to a stream ID, and then we will pass the local audio source that you have watched above, that how it's been created. So for the local stream, which is a media stream object, we want to initialize it using Peer Connection Factory and create local media stream function. We simply pass the stream ID to it, and after creating the local stream, we add both tracks to it, local audio tracks and video tracks. So our local stream is ready now to be added to a peer connection. After local stream is being added, we will use this callback, which is instantiated down below. And this callback is responsible to notify the view model that the local stream is ready to preview. So we use this callback to send it up to the view model layer. We do have the onDestroy function, which stops our stream and capturers. And also the last function in this class is to create the RTC clients, which will drop this RTC interface. As you can see, there is an WebRTC client here that has some abstract function within it. So we have the peer connection, onDestroy, answer, on remote session received, on ice candidate received, and on local ice candidate generated. Let's take a look inside the RTC client's implementation. So let's take a look on this implementation and see what happens inside this one. Then go back to our factory and take a look at how this function creates us a WebRTC client. There is a base remote message model that has the answer command inside it. This one is always set up as answer because the flow goes like we request an offer from the server on both clients. I mean, streaming and watching clients both will request for offer, and then we have to create a message model which the type or the command is the answer. So on both scenarios, we will have answer as return, Down below, we will have the media constraints object, which has some key value pair of offering video and audio to mandatory. For the peer connection variable, we simply return the peer connection that we will get, through the constructor of the class. Now it's time to override the functions that we had inside this one. For the answer, we will get the ID. First thing to do is to reset the local offer, which will instantiate the message model again and add the ID of stream to it. So we know what ID we are responding as the answer. So after that, we'll create the answer object and set it inside the peer connection as the local description. And whenever it's ready, we will create the session description object. And you will see there's a delay here. And then we will call the callback to transfer this message model to the server. So what goes here is that we are preparing the whole a message model package at the same times and send it to the server as the offer. This goes the same for our Oven Media Engine. There's the same attribute. It packs the ICE candidates and the session description at the same place and send it once as a message model to us. So we have to do the same attribute. By the time that we start creating an answer, there would be, some ICE candidates being gathered. So when the user tries to answer, it creates the session description to send it to the server. It will wait like 3 seconds to gather all the ICE candidates. And meanwhile, we are generating the session description. Our peer connection will gather some ICE candidates. So we use this function to add a local ICE candidate to the message model that we want to send it to the server. You can see that we add the ICE candidate to peer connection, also add the candidate inside the candidates object, which is this mutable list, the new ICE candidate, my ICE candidate object to it, and prepare the list of remote message models ICE candidates. So after 3 seconds, we will have a message model, a remote message model assigned with session description and also ICE candidate gathered at the same place or same list. And the rest of the function is pretty much straightforward. When we receive the remote session, we want to add it as the remote session. When the ICE candidate, remote ICE candidate is being received, we want to add it to our peer connection. Also for the undestroy, we'll simply want to close the peer connection. Simple as that. So we know how to create a WebRTC client here, which has the answer button as the key button or as a key function. It will wait 3 seconds to gather all the ICE candidates and add it to the remote message models candidates array list. And then when prepared after 3 seconds with the answer, we want to send it to the socket server as a message object. So let's go back to our WebRTC factory and check what happens and how we create the RTC client object. So first thing, to use this RTC client implementation, we want to create a peer connection. Using peer connection factory, we want to create a peer connection, and to do that, we want to simply add the ICE servers to it. And for the observer, we will use the observer, which is within this function, which is derived from this function. So we check if our local stream is not null. We want to add the local stream to our connection and then return this connection using instantiation of client's implementation, pass the connection to it and the listener that is derived from the function. So that's it for this video. This video is already too long. Let's move to the next video and start streaming. So till the next video, see you everyone.